In this video, we'll analyze and describe the general process for row reduction and then show an example of how this works in practice. What's the idea of row reduction in general? Well, the idea is we want to find a systematic process for solving these matrix equations in a way that will always get us to the answer eventually. We don't want to be doing random things or things in random orders or not knowing what we're doing. We want to have a systematic way that will always get us through this process to get to an answer and a conclusion. It might not be the easiest way, the most straightforward, the most direct way, but it's always going to get us to an answer at the end of the process. So how do we start? Well, step one, once you have your system already in the appropriate matrix form, is to swap rows if needed to put a non-zero entry in the top left corner of the matrix. And this comes from our E1 operation of being able to swap equations or swap rows in the matrix. Step 2 of this process is to make that non-zero entry a 1 by dividing the whole row by that first entry. So divide the entire first row by the entry in the top left corner to make a 1 in that spot. And this ties to operation E2, allowing us to divide or multiply an entire row by any constant. The third step is to use that 1 in that top left entry to cancel out everything below it so that that first column is now 1, 0, 0, 0, 0. And to do that, we are going to add or subtract copies of row 1 to each of the rows beneath it to make those entries be 0. And this comes from operation E3, which allows us to add multiples of any row to any other row. So with those 3 steps, we have now made a good bit of progress towards our row echelon form, because now our first column is what it should be for a matrix in row echelon form. We have a leading 1 in the first entry, and below it are all zeros, meaning that the next leading entry in other rows is going to be further to the right than that first one. So this is good. We've made progress so far. What do? Now that we've made progress, we don't want to get rid of that progress. So now we are going to fix or freeze row 1 and column 1. We will not use row 1 or column 1 for any of our future steps, because if I do that, I'm going to mess up this first column being 1, 0, 0, 0, 0. So now that I've blocked off row 1 and column 1, I can sort of step inside to a smaller matrix. So now my top left entry is row 2, column 2. I can repeat the exact same process now with that smaller system. I can now swap rows to make sure I have something non-zero in row 2, column 2, or my new row 1, column 1. Make that a 1, cancel below it, and repeat until we're in row echelon form. And based on the way this process works, it will always get you to an appropriate row echelon form at the end of the problem. I'll make some points now about this process before we go on to an example of this. So there is some choice in how you carry out this process, things you want to keep in mind as you're going about solving these problems. For instance, as you see in the example here, if I have a non-zero entry in row 1, column 1, but somewhere else in column 1 there is a 1, maybe I want to swap rows anyway, but instead of dividing a whole row by some number and getting fractions, I can just swap rows and put a 1 up there automatically and have no fractions. So you can make some choices here as to what you want to swap or how you move things around to minimize the number of fractions you'll see over the course of working out this problem. But besides what row you swap and what you put where in terms of the different rows, that's the only part that really has any choice. The rest is all formulaic from there. Get something in the top row, put a 1 in that spot, and cancel below it. Swap things around, put a 1 in that spot, cancel below it. The process just keeps going that way. And if you follow this process directly, it'll give you a straightforward path to get to the answer, to get the result you want for this problem. Let's also see an example of this process here in action. I have this system here of equations that I want to solve by reducing to row echelon form. So I've got minus 4x1 minus 6x2 plus 8x3 equals minus 8, x1 plus 2x2 minus 4x2 equals 7, negative 13x1 minus 18x2 plus 17x3 equals negative 5. So we start by writing the augmented matrix form of this system. Now we can go forward with our process. So if I wanted, I could leave this as is and divide the first row by minus 4, put a 1 in that spot and go forward from there. If I do that, I'll see a 3/2 in row 1, column 2, which is an okay fraction. It's not too bad. So I could do that. What I'll do instead here is I'm actually going to swap rows 2 and 1. So I put that 1 that's already there in the top spot, and then I have no fraction for the next step. You could also, if you felt like it, swap row 3 up to row 1 and then divide by minus 13, but then everything has a fraction and nobody's happy. So we're going to swap rows 1 and 2 here to put that 1 already into that top spot. Now that I have my 1 in the top left corner, I can use that 1 to cancel out the 2 rows beneath it. How do I do that? Well, how do I make that -4 in row 2, column 1 be a 0? Well, I have to add 4 to it. So what I want to do here is make my new row 2 to be the row 2 that was before, plus 4 copies of row 1. If I do that, I will get a 0 in row 2, column 1 because I've added 4 to that -4. So I'm not changing the first row, it stays the same. You want to keep that in mind for these problems. If you're going to use a row in an operation, you can't change it in the same step. So I couldn't also do like row 1 is row 1 plus 3 row 2 in the same step because I'd be mixing these things together. Now, I'm going to add 4 copies of row 1 to row 2. So -4 plus 4 is 0, as it should be. I have -6 plus 4 times 2, so that's plus 8, so that's positive 2. I have 8 plus 4 times -4, so that's 8 minus 16 is -8. Then I have -8 plus 4 times 7 is -8 plus 28 is positive 20. Now, if you want to take this process slower, you could rewrite row 3 here and then use the next step to get rid of row 3, but I'm going to do it all in the same step. So for my next step, I want to get rid of that -13 in row 3, column 1, and I want to use row 1 to do it. I always want to use row 1 for these steps. So how would I use row 1 to do that? Think to yourself for a second. For that, I want to use row 3 is row 3 plus 13 times row 1. That'll give me -13 plus 13 is 0. The second entry, I have -18 plus 2 times 13, or plus 26, so that's going to be a positive 8. For the third entry, I have 17 minus 4 times 13 is 17 minus 52, which is -35. And then the last one, I have -5 plus 13 times 7. 30 times 7 is 70 plus 21 is 91, minus 5 is positive 86. Okay, there's our next step. Now, we have column 1 in the appropriate form. It is 1, 0, 0, which means I do not want to mess with column 1 or row 1 for the rest of this process. Where can I go from here? Well, now we're in the same spot. I want to get a 1 into row 2, column 2, or my new row 1, column 1 with the part that I'm ignoring. At this point, the third row is not any better, so I will just divide the second row by 2 to get a 1 in that spot. So row 2 divided by 2, we leave the first row fixed as we should. Second row we divide by 2, 0, 1, minus 4, and 10. Third row stays the same for now. All right, now I want to use that 1, which is now I'm focused on this 1 here, and use it to cancel out the 8 below it. How do I do that? I'm going to subtract 8 copies of row 2 from row 3. The next operation here is row 3 equals row 3 minus 8 row 2. Again, notice we are not doing row 3 is row 3 minus 4 row 1. That would give me a 0 in that spot, but it would also put a minus 4 in row 3, column 1, which I do not want. So we're just using row 2 here. Now the first 2 rows stay the same. And for the third row, that's still a 0 because it's 0 minus 8 times 0. We have 8 minus 8 times 1, which is 0. We have -35 minus 8 times -4. -35 plus 32 is -3. We have 86 minus 8 times 10. 86 minus 80 is 6. This would be an okay place to stop at this point, but you could also go further if you want. What happened to go further? You would divide row 3 by -3 to put a 1 in that spot. And then you could also, if you want to go to reduced row echelon form, do the back solving as well, where then you use row 3 to cancel out the entries in rows 1 and 2 in column 3. Then you use row 2 to cancel out the entries in row 1 in column 2. I'm going to stop here because this is usually where most people like to stop with this problem. And now we can rewrite this as equations. So as equations, what does this tell me? Well, this tells me x1 plus 2x2 minus 4x3 equals 7, x2 minus 4x3 equals 10, and -3x3 equals 6. Well, now we're in good shape because this last equation tells me right away that x3 is -2, dividing both sides by -3. I can then take that x3 and plug it into the x2 equation. So then I get that x2 is going to be 10 plus 4x3, or 10 plus 4 times -2, 10 minus 8 is 2. And I can plug both the x2 and the x3 into the x1 equation. So that x1 will be 7 plus 4x3 minus 2x2, which is 7 plus 4 times -2 minus 2 times 2 is 7 minus 8 minus 4, which is negative 5. So therefore, my answer here is x1 equals negative 5, x2 equals 2, and then x3 equals negative 2, or as a vector, minus 5, 2, and negative 2. So that there gives you the general process of row reduction. Well, as an example of working it out in detail step by step to get to a solution to this linear system of 3 equations and 3 unknowns.